All right, so let's go through the free response problems. This one's talking about an experiment. Not a lot of math set up here. They're just going to walk you through the different things you need to know. So what is the factor in this experiment? Did y'all see that?
Yes.
The number of sugars.
All right, so
I don't remember.
number of tablespoons of sugar.
Can you just put amount of sugar?
Sure, amount of sugar would be fine. Response variable,
Hours of freshness?
hours of freshness. So what are the treatments then?
That would also
So be a little bit more specific. So the difference here is that you're looking at the specific treatments that they got. And based on that, it looks like 0 tablespoons, 1 tablespoon, 2 tablespoons, 3 tablespoons were the treatments. But there were 4 treatments. What are the experimental units?
carnations.
It's the carnations. All right. What is the treatment being applied to? And that's the carnations. Carnations. Is that spelled right?
Yeah.
Okay. Give 2 examples of how the students use control and why it was important to this experiment. So remember the difference between control and control group. Control group is when you have one group that doesn't receive treatment, but that's not what they're talking about here when they say control. So don't refer to the 0 tablespoon group. Instead, what did they do to make sure that everything else was the same other than sugar?
The amount of water.
Amount of water.
Identical bases.
Is the same. What the other one?
Identical bases.
They used identical bases. Any others that people saw?
They're in the same location.
Same location. All very important things. Sorry. Did the students use blocking in this experiment? No, there's no indication that they did. All right, so what would be an example of blocking appearing? Do you remember what blocking means?
What do you mean? Like, if they put them into groups of 0, 1, 2, and 3 tablespoons?
Okay, but it kind of sounds like they did.
What, I mean, like, there are 4 different groups, and in each group there are 4 flowers. One has 0, one has 1, one has 2, and one has 3.
Okay. But what would that be different? What would be different about the groups other than that? Okay, so if you wanted to look at another factor, but be careful, you don't want it to be another treatment. So blocking should usually be something that already exists in them that you want to look at a difference in. So what is something that could have been different about the carnations other than the stuff we controlled and the stuff that, and the treatments we used?
The day they were
Hmm?
the day they were like plucked.
Okay, so maybe like something about where they came from or how old they were before you got them. Maybe different colors. Okay, so blocking is dividing before treatment based on existing properties. And that's not the most complete definition of blocking. But for this case, that's what it would need. And so like if it was colored, then maybe we would take all the white carnations and we would make sure that some white carnations got 0 tablespoon, 1 tablespoon, 2 tablespoon, 3 tablespoons. And then the pink carnations, we would make sure some of them got 0, 1, 2, 3. because we wouldn't want color to be a factor that just randomly maybe the pink in our random assignment got more sugar than the white and the pink ended up doing better. Well, maybe the pink was the reason and not the sugar. Explain why this was an experiment and not an observational study.
Because they're actually doing like experiments.
They're manipulating a variable.
They're manipulating a variable. And how are they manipulating it?
Like they're determining like how many teaspoons of sugar the flowers can get.
Okay. So I would go with that. So assigning sugar treatments. Sugar. To each carnation. Only thing I would add is that to be a good experiment, they would need to be random assignments. Okay, so I'm just going to make that note here to make sure you remember that. Assignments should be random. Did it say they were? All right, so the students performed a regression analysis on the data, and they got the results below. So before we get to questions, from the graph, do you think there's a relationship? Looks like there's some kind of relationship. And can you see that same relationship somewhere on the computer output? Remember that there's a lot of stuff on the computer output that we don't use. Right now, we mainly care about these numbers and then our R² value. We're not really worried about everything else right now. So the question is, what is the equation of the regression line? To do that, we're going to look at the top two numbers right there. And so it's going to be y hat, meaning a predicted y, equals, what's our slope? 15.2. How do we know that one's the slope? That, right. You're going to look right next to the factor. It's usually that bottom one. So that one's your slope. You can also kind of see on the graph if you try to estimate from the graph. So the other one, the constant number here, that's going to be your y-intercept. So what was that number? 181.2. So now we want to interpret the slope of the regression line in the context of this experiment. We would say for each, and this is always going to be x going up by 1, so additional teaspoon of sugar and then we're always going to put it in context of what y is doing. So since it's a positive 15.2, we would say the hours of freshness increases by 15.2. I already said hours, so you could say freshness increases by 15.2 hours, or time of freshness also. It's been a while since we've done R squared. Do y'all remember how to interpret R squared?
No.
So what was R squared?
Can
Sure.
we write those on our flashcards?
Yeah, these are great things for your flashcards. I want you to worry less about formula and more about little reminders for things like this. So if you want to put any scripts on there, then definitely do. Okay. All right. It was 86%. So 86% of the variation in what?
In Y context.
in whatever y is. So your y in context. So in hours of freshness, can be explained by the linear model or the linear relationship between them. Explained. Oh.